Okay, this is continuity of functions. Okay, and most of us pretty much have a good idea what a continuous function is. If you don't, I'm just going to tell you that if you can draw the function without lifting your pen or pencil off the paper, it's continuous. So you probably already knew that. If you're watching this video, you're probably watching it because your math teacher wants you to state the obvious. So in order to state the obvious, like most math situations, we got to have some rules, okay? And I just make sort of a checklist on one of these things, okay? While you're working through problems until you get this down, we're just going to stick by this little checklist, okay? So, first of all, f of c. So, first of all, this definition of continuity applies to continuity at a point, okay? It doesn't generally apply to the entire domain of the function. So what we do is we just pick a point. Let's just call it C, okay? So we ask ourselves, number one, does f of c exist? If so, does the actual limit of the function exist? And if that's the case, does the limit of the function equal f of c? So let's just go ahead and look at a real function real quick. Okay, so here we got, what is this, half of a circle? Okay, first of all, before we even get going, let's just find the domain of this thing. Let's find out where it's defined. Obviously, it can't be continuous where it doesn't exist. So basically, the domain of this function, f minus, or 4 minus x squared, actually it has to be greater than 0, okay, because it's going underneath the radical. So I'm just going to move the 4 over, and it looks like we'll have to do some dividing by a negative, so that'll reverse the sign convention. And we end up with, of course, you probably already knew it, absolute value of x less than 2. So we'll go ahead and we'll say x is okay. So both these things are true. So obviously, let's just go ahead and graph it real quick. So here's 2, and here's negative 2. And since this is half of a circle, it's going to look like this. If you went up here and solved this for what y would be, you'd find out that the radius was 2 as well. But that's not what we're after. We're after continuity. That's half of a circle. I know it looks bad. Okay, so first of all, we can just go ahead and ixnay everything that's, greater than 2 and everything that's less than negative 2. Okay, so let's say I pick, let's say I pick 1. Say I want to show continuity at x equals 1. So x equals 1, okay? So first of all, let's go back to our little checklist. Does f of c exist? Okay, let's find out. F of 1 equals 4 minus 1 squared, okay? Which equals square root of 3, which is like 1.73 or something like that. Okay, so it does exist. It's defined there. Check. Okay. Oh yeah. Number 2, the limit of f of x as x approaches c exists. Okay, so let's take the limit of this baby. That's a pretty easy one. It looks like we just use substitution in this thing. As x approaches 1, this whole expression approaches 4 minus 1, which approaches square root of 3. Okay? Alright, so limit of f of x as x goes to c, check. Got it. Okay? Oh yeah. Next thing. Does the limit of f of x equal the limit of f of c? Okay? Well, we found that f of 1 was in fact equal to the limit as x approaches 1 of, because they both approach square root of 3. Okay, so we can go ahead and say that this thing is this function is continuous. Okay, so you see how I did that? I just went through my little checklist here. Okay, so basically, if the function is defined at c, okay, and the limit as x goes to c, let's just take a look real quick. Check out. Let's just say that the first two requirements were met. Okay. And let's say I had one of these functions. You've seen these before, I'm sure. And here's C. Okay, well, this situation, f of c would be defined. It's up here. So we would put a check right there. Number 1 would be good. Number 2 would say the limit of f of x exists. Well, yeah, sure. They both approach, f of c. Okay? So we'd put another check there. That would work. But number 3 is kind of like our catch-all law right there. Well, does f of c equal f of x? Okay? Well, f of c is right here. The limit, however, is down there. So it violates rule number 3. So this would be an example of something that would not follow the continuity test at a point. Okay? And likewise, okay, say you get one of these functions, okay, and it has let me make one that's really just ridiculous. Okay? So here you got a function right here. Well, anytime you have a function that looks like this, yeah, no shit, it's discontinuous. But just on paper, without even graphing this, if you were to look at this, you would see the equation for this thing. It would be piecewise defined. Okay? So you would have probably in this case 4 different equations over here, and it all have their own unique domain. Okay, this one looks somewhat linear. This one looks like a degree 2 polynomial. This one looks like it's like a degree 3 or something. So like that. So right off the bat. And again, this is stuff you probably already knew. It's just that this handy little list right here is what's going to kind of help you out as far as showing your math teacher, yeah, it's continuous, and I can do operations on it, because basically there's not a lot you could do with a discontinuous function. Okay, you can't take a derivative, you can't integrate them, so. They're going to want you to go ahead and show, that the function is in fact continuous at a point, and it's fairly obvious. It's just the hard part is just showing it mathematically. Okay, so I hope this helps. If it doesn't, like I said, each and every time, just send me a message or a comment, and I'll do some examples of something like this. Thanks for watching.